Thanks, and good morning. It's wonderful to have you all here today. This morning, you're getting a glimpse of the future of space exploration. During the Apollo era, which ended now 40 years ago, we had single astronauts, the last and only time we explored the surface of extraterrestrial bodies. Single astronauts out on their own, doing the best they could to collect geological samples and to return those, but really it was one person kind of operation. The future is going to be an astronaut or a series of astronauts in control of a fleet of rovers. Either if you're on the surface of a planetary body like the Moon or Mars, or from orbit. And that interface between humans and robots is going to be much more powerful, much more effective in terms of how we can explore and to gather scientifically valuable information. So whether those be samples from the far side of the Moon or samples that might have life associated with them on Mars, or even in the future going to places like Titan in Europa, doing teleoperation from those. Or in our case today, as Terry mentioned, our experiment, which we've been working on for some time, is the idea of being able to place the first low-frequency radio telescope on the far side of the Moon using telerobotic deployment. Why is that interesting? Because the far side of the Moon, first of all, we've never been there, either with robots or with humans. Secondly, it is the only place in the inner solar system that is radio quiet. The kind of frequencies we're looking at to explore the early universe are 100 megahertz and below. That starts off right in the middle of the FM band. That's no man's land. The other thing is the ionosphere, which sits above our head. That also deflects signals which are coming in at low radio frequencies. The far side of the Moon is a location that is free from those effects. What we'll be able to do at these low radio frequencies is to probe for the first time when the first stars and the first galaxies form. We can't do that with the Hubble Space Telescope. We won't be able to do that with the James Webb Space Telescope. It requires operations at these very low radio frequencies where we can probe the gas around those stars and galaxies. So it's a very exciting opportunity, and I've really appreciated the opportunity to work with Terry and his group, who've just been fantastic in embracing our science and doing a demonstration with this thin polyimide antenna material. So looking forward to talking with you all more this morning. Thanks.